Okay, so now we're going to talk about reducing the sources of greenhouse gas pollution. I already told you that this is going to be key to addressing climate change. We're going to stop the problem before it even gets into the atmosphere. And that's the way we need to begin. So we're going to zoom in and look at all the different contributors to the sources of greenhouse gas pollution and how we can bring these things down to zero and stop the problem at its tracks. Well, what are the sources of this greenhouse gas pollution to begin with? Well, you've heard of a few of them, but some of them are going to be kind of surprising. One of the places we should begin is the biggest emitting sector of greenhouse gases, which is making electricity. It turns out that burning coal in a power plant or natural gas creates carbon dioxide, and that is a big contributor to climate change. Overall, across the world, it's about 1/4 of the problem. In some countries it's bigger, in some countries it's smaller, but the globe as a whole is 25%. The next biggest source of greenhouse gases often surprises people, and it's 24%, is food. It turns out that growing food and agriculture and the land use associated with all of that together is about 24% of our emissions. Isn't it weird that electricity and food are about equal and together are half of climate change? We hear a lot more about the electricity space, though, than we do the food space. It turns out they're about equally important. Then we switch over to industry, kind of making all the stuff in the world. We'll go through a lot of those different things, but making steel and cements and plastics and other things, as well as managing waste, is what's happening here, and that's 21% of the problem. Then we've got transportation, moving us and our goods around the planet, whether it's a car, a truck, a plane, a ship, and whatever. That's about 14% of the problem. Then we go to buildings. Buildings cause about 6% of climate change. But to be fair, buildings also are using a lot of the electricity. They're responsible for some of the industrial emissions to make the components of buildings. And of course, transportation takes us from building to building. So buildings directly, from their furnaces, their hot water heaters, boilers, and air conditioners emit greenhouse gases, but they have a big effect on a lot of the other sectors. So how we build buildings and what we do with buildings and the design of cities is crucial throughout all of those wedges of our pie chart. Then we've got the remaining 10%. That's a lot of different things, but it's actually dominated by the energy industry. It's going to be responsible for things like fugitive emissions, the kind of leaks of methane and natural gas that aren't intentional, or when they flare off natural gas in an oil well, or the emissions when we refine crude oil into things we use like diesel fuel, gasoline, and so on. So energy industry and a few other things show up in the last 10%. But look at the first 5. It's kind of amazing that only 5 things, electricity, food, industry, transportation, and buildings, cause 90% of climate change. Well, heck, that's just one hand. We can solve 90% of the problems with just this. That's pretty good. So let's go through each of these sectors and kind of see what can we do to reduce these emissions and eventually bring them down to zero. So we're going to look at each sector, and then we're going to dive into particular solutions. And we're going to show you how at Project Drawdown, we've tried to estimate the size of these different solutions and which ones might work best. So let's start with electricity. Electricity, again, produces about 1/4 of the world's greenhouse gases. And the production of electricity burning fossil fuels, especially coal and natural gas, causes those emissions. But we can also look at how electricity is used. Most of the world's electricity is used in buildings, for lighting and air conditioning, heating, refrigeration, all those kinds of things. And about the other half or so is used in industry, making stuff, big industrial, big machine processes. The rest is about 2%, and that's used in food and transportation and everything else. So buildings and industry are the big users. Well, let's make this kind of real. Burning coal and natural gas in a power plant is what produces these emissions, and that's what makes electricity, and sometimes we use the heat in a power plant for something else as well. We take that electricity, we put it in buildings, industry, and everywhere else. And the kind of electricity we make is associated with the electricity that's in the grid, but also the greenhouse gases we put in the atmosphere. For example, burning coal releases about 2 pounds of CO2 for every kilowatt hour of electricity we use. Natural gas is a little less. It's more like 1.2 pounds of CO2 for every kilowatt hour we produce. Then we have solar, wind, nuclear, and other forms of making electricity that don't produce any CO2. So this is a big difference between the fossil fuels electricity and the non-fossil fuel electricity. It's a huge, huge difference. Now let's make this real. A kilowatt hour is what we use to measure electricity consumption. A kilowatt hour is like using 1,000 watts for 1 hour. A hairdryer uses about 1,000 watts. So if you turned on a hairdryer and left it there for an hour, that's 1 kilowatt hour of electrical use. Pretty simple. Well, the average American home uses 1,000 kilowatt hours every month, on average. Some use more, some use less, for all the different things we use electricity for. Well, if we do the math, 1,000 kilowatt hours on America's electrical grids, which releases on average about 1.4 pounds of CO2 for every kilowatt hour, that means an average American home is responsible for over 16,000 pounds of CO2 pollution, or over 8 tons. That's incredible. How would we reduce that? Well, we already kind of know, don't we? We can have energy efficiency. We could reduce the use of electricity. No matter how the electricity is made, we could probably cut it in half with better lighting, better air conditioners, better appliances, and so on. But then we can also switch the way we make electricity to things like renewables that don't emit any CO2 at all. So that 1-2 punch of efficiency and transforming to renewables is key here. While Drawdown, we looked at those solutions not at your home level, but at the larger economy level, at the whole planet. And we looked at a whole bunch of solutions that could enhance efficiency, many of which are in buildings and automation, are all listed here. And we also looked at ways we can shift electricity production away from coal and gas to things like solar and wind, hydro, geothermal, biomass, nuclear, and beyond. We also have to do a few other things, by the way, like improving the grid. We have to have electricity dispatched and stored in new ways to accommodate renewables. And we also have to have more flexibility in how electricity is used. But if we put all these things together, a whole bunch of efficiency solutions, a whole bunch of solutions about producing energy in new ways, and improving the grid, we have an enormous suite of climate solutions right here in electricity. In this picture, each of those solutions is represented by a single circle. The bigger the circle, the bigger the climate solution. Some of those circles actually have 2 rings, an inner one and an outer one, and that kind of represents a range of estimates we've made about how big that solution could be over the next 30 years or so. So there are a lot of good solutions here in efficiency and making electricity in new ways. Really exciting. Well, let's look at food. Food's also a big emitter of greenhouse gases. Again, about a quarter, 24% of our emissions come from food. A lot of folks, though, think the food emissions come from things like moving food around or food miles you might hear about, or if we grow food maybe organically or with conventional ag or GMOs. We talk about that stuff all the time, but it turns out those aren't the big issues. The really big issues in agriculture emissions for climate change are actually 3 other things. They're deforestation, kind of burning down forest for new agricultural land. Most of the deforestation on the planet today is happening in Brazil and Indonesia and a few other countries. In Brazil and Indonesia, we're clearing a lot of land for cattle and soybeans that are used to feed animals, mostly in Brazil. So animal agriculture is hugely responsible for deforestation there. In Indonesia, it's mostly for palm oil, being used as a cooking oil, mainly in China and India, but also used as kind of an ingredient in a lot of other foods. The next big area is methane from our animals and a little bit from rice fields. And again, animal agriculture is really important here because cattle and cows burp methane, as we talked about before, and that methane builds up in the atmosphere, causing a big level of new climate change. Basically, we're going to have to rethink meat and dairy products in order to reduce those emissions, either having a lot less of it or growing it in really different ways. Then we have nitrous oxide, that gas I talked about before, which is often produced by using fertilizer too much. Whether that's fertilizer that's chemical fertilizer or manure, they both have nitrogen in them. And if we put too much on a field under certain conditions, that nitrogen can come off into the atmosphere as nitrous oxide, a major greenhouse gas. A lot of the rest, by the way, will run off into the water and cause pollution in streams and watersheds and lakes and even entire oceans. So managing nitrogen and fertilizers is going to be a real big problem, both for climate change, but also for ecosystems and our water. So to solve those problems, we can again look for efficiencies, things we can do to reduce the pressure on the food system. It turns out the biggest place to start is food waste, because we throw away about a third of the food grown on the planet. Food waste is so crazy. In rich countries, we use far too much food and throw away a lot of it, and it's never even eaten, and that's just tragic. In poor countries, though, food waste is often about the same number, but it happens closer to the farmer, because maybe the crop didn't get to the marketplace. Maybe it rotted in storage, or it never got on the truck, or the train broke down. So we lose food there too, and the farmer loses their income. Kind of a double tragedy. So food waste is actually a huge problem, not only for climate change, but food security and a lot of other things. It's a problem worth solving. We also have to think about diets. I showed you how meat and dairy products were responsible for a lot of the big drivers of these emissions. So eating more plants and less meat-based products is a really simple, kind of easy, thing to do. If meat and dairy are responsible for a lot of emissions, let's eat a little less of that stuff and then grow what we do eat better. We also have to protect ecosystems from being cleared. Can we put up big fences and just say no to deforestation, stop them in their tracks? Make sure we don't clear forest, and especially forest with peatlands under them that have carbon in the trees, but carbon in the peat below ground. But then finally, we can also improve the way we farm on the lands we still are farming. That's going to be a whole bunch of different things, about using water better and nutrients better, tilling the soil less, putting on cover crops, all sorts of things. And you'll hear a lot of excitement about regenerative agriculture, which kind of mimics nature's way of doing things as we farm. Regenerative agriculture and these other farming practices can reduce emissions a lot, and that's really crucial. Later, we're going to talk about the potential of some of those farming techniques to not only reduce pollution, but also create new carbon sinks that might absorb CO2 and put it into the soil. That's pretty cool too. But for now, we're just talking about reducing the emissions from farms. Well, let's put all this together. It turns out by looking at all the food solutions, we see food waste is huge. Changing our diets can be huge. Protecting ecosystems, especially forest and forest with peatlands below them, are really important. And farming differently is a major contributor too. So the solutions to the food system climate problem are partly due to us, partly things about ecosystems, and partly what's happening on the farms. We can all do our part here. Well, then let's flip to industry. In industry, we make a whole bunch of things that take high temperature, very intensive processes to make, like metals, especially steel. Steel is a big contributor to climate change. Cement. Making cement releases a lot of CO2 into the atmosphere. Our chemicals, and also plastics, things like that, each make some CO2 as well. By the way, we hear a lot about plastic being a big climate problem. It is. It's about 1.5% of climate change is tied to producing, using, and disposing of all the world's plastic. Definitely a problem, but it's even more of a problem out in the larger environment because it's affecting marine ecosystems and causing pollution in all sorts of other places too. And then finally, managing waste. And the gases used in managing waste, but also released from landfills, is crucial. We're going to look at that too. So we're going to look at all sorts of industrial processes, manufacturing and materials, and how we process and manage waste across all of those different domains. At Drawdown, we've looked at a few already and put numbers on them, like what can we do with cement, what can we do with plastics, and then we look at a specific suite of chemicals called refrigerants, which are all these fluorinated gases. It turns out that fluorinated gases like chlorofluorocarbons are very dangerous. Back in the 70s, we realized that chlorofluorocarbons were actually hurting the ozone layer way up in the upper atmosphere. They also contributed to global warming. But we phased out most of those chlorofluorocarbons and replaced them with hydrofluorocarbons, or HFCs. Those don't hurt the ozone layer, thank goodness, but they still contribute to climate change. So they're ozone friendly, but not climate friendly. We're going to probably have to replace them again and replace them with climate friendly refrigerants and make sure that none of the existing refrigerants leak and get into the atmosphere. We've also looked at ways we can use waste as a resource. Rather than throwing something away and never using it again, the kind of recycling, repurposing, and actually using energy from our waste streams is a really clever idea, which makes just all sorts of sense. So if we think about improving materials, especially refrigerants, and using waste as a resource, we have a lot of solutions already appearing in the industrial sector. We've got a few more to work on, especially steel and a few other things, but we've got a good start here. Then we got transportation. Transportation is about 14% of the problem. Most of that is on road transportation. 10 of that 14% is in roads, cars, trucks, things like that. The flying we do, aviation, is a little less than 2%. That's all the commercial and military aviation on the planet is about 1.8% of global emissions. Everything else is another 2% or so. That's going to be ships and trains and other things. But mainly it's roads, planes, and the rest. CO2 is made here, that's pretty clear, by burning the fuels we use in transportation. Gasoline, diesel fuel, jet fuel. When we burn these liquid fuels, it releases carbon dioxide into the air. Well, let's take this to everyday life. Like, imagine a gallon of gasoline. You pick up a gallon of water, it weighs about 8 pounds. Gasoline's a little bit lighter, call it 7 pounds. If you burn a gallon of gasoline, which is mostly made up of carbon, you add oxygen to it, 2 atoms of oxygen for every one of those carbon atoms, that 7 pounds becomes 20 pounds of pollution. And that 20 pounds of pollution goes into the atmosphere, right out of your tailpipe, and goes into the air and stays there for centuries, long after you're dead. Can you imagine that? Just burning 1 gallon of gas releases 20 pounds of pollution that could be up there for 1,000 years, maybe? That's incredible. So it turns out driving the average American car, which gets about 25 miles per gallon, driven about 15,000 miles a year, produces almost 12,000 pounds of CO2 pollution, which will last for centuries. That's about 6 tons of pollution. It's more than your car weighs, is what we put in the sky by a big margin. Fuel efficiency is crucial, though. If we go from 25 miles per gallon, which is crazy low, to 50, which is just kind of modest at this day and age, we can actually take that 12,000 pounds and bring it down to something like 5,000 to 6,000 pounds. That's a good step. Planes, again, use about 1.8% of the problem here, and that's caused by just burning aviation fuel in those planes, releasing CO2 as well. But we're getting a little bit more efficient in aviation. Today's planes use about 50 to 60 miles per gallon equivalent for every passenger on the plane. It'd be like driving a hybrid car. But the problem is you're going a lot of distance really fast and you can keep doing it. So when we think about transportation, we can look at efficiency, making the current things more efficient, like fuel efficiency in cars, more efficient airplanes, more efficient trucks, and so on. And we can also look for alternatives to fossil fuel transportation, like walking, bicycling, mass transit, or video conferencing, where you don't have to go anywhere to hear other ideas or meet other people. Those are all really great. And then we can switch from a liquid kind of hydrocarbon fossil fueled vehicle to an electric vehicle. Electric cars are here to stay. They're better. They're going to be cheaper. They're going to be fun and useful and cheaper to operate. We're getting electric trains, of course, electric trucks and other things. This is really crucial. But putting this all together, efficiency of our current vehicles, shifting to other ways of getting around, and then electrifying our new vehicles, there are a lot of great solutions to transportation. Okay, let's get to buildings. They emit directly about 6% of greenhouse gas emissions. But again, they're affecting electricity, transportation, and other areas as well. But what buildings emit directly within their building envelope are primarily from residential buildings. About 2 to 1 of these emissions are from homes and apartments compared to public and commercial buildings. So we're talking a lot about homes, apartments, as well as big public buildings too. Well, we emit greenhouse gases directly from buildings in our furnaces and boilers and hot water heaters, because they're going to burn natural gas or maybe fuel oil, heating oil, things like that. And those emit CO2 right from your basement. But buildings can also release refrigerants from air conditioners and refrigerators kind of accidentally if there are any leaks in your air conditioning equipment or your refrigerators and your freezers. That's why we always should be tuning those up and watching them. In a typical American home, we actually use a lot of natural gas to heat our spaces, especially in a cold place like Minnesota, where I live. or to heat our hot water for taking showers and things like that. And we measure natural gas in what are called therms. A therm is 100,000 BTUs worth of heat, and that's what your gas meter is measuring it in. The average home in a cold part of America uses about 1,000 therms every year, and that would add up to about 13,000 pounds of CO2, more than your car in a lot of cases. So again, we have to think about electricity and transportation, but also the energy used within our buildings, often as natural gas or heating oil, in order to tackle climate change. So that's why building efficiency matters so much. A lot of buildings are still too inefficient. They leak heat out. They pour heat in during the summer. We can make buildings really much more efficient. We can always build new green buildings, of course, but we're going to have to do a lot to retrofit the hundreds of millions of buildings that already exist. Then we got to shift to new energy sources that don't burn fossil fuels to heat our homes, cool our food, and give us nice hot showers. And we've got to pay special attention to the refrigerants in air conditioners and freezers and refrigerators, because when those leak, they become a kind of super pollutant, causing disproportionate climate change. When we look here, we see energy efficiency, shifting energy resources, and addressing refrigerants are going to be the crucial aspects of buildings in climate change. Let's wrap up here. Now we've got the last sector, which is everything else, the other category, about 10%. A lot of this is from the energy sector itself, when they flare off natural gas in an oil well, or what are called fugitive emissions, which are kind of the emissions that escape accidentally from a fracking well of natural gas, or a coal mine, or a leaky natural gas pipeline. These are things we should demand the energy industry address right now. These are super low-hanging fruits that if the energy industry cared at all about this, we could shut off like 6% of climate change today. So what have we learned? We've learned that attacking the sources of greenhouse gases are the first biggest step to addressing climate change. And there are big 5 areas we should be focusing on: electricity, food, industry, transportation, buildings, and so on. And we can see those here. But then inside those major sectors, we have hundreds of little areas that are all really important to address if we want to solve climate change. There's absolutely no silver bullet here. We do a lot of individual things between flying and cement and plastic, electricity and buildings and food and meat and everything else. All of those little things contribute to climate change. So we're going to have to do a lot of little things together to solve climate change. There are many sources, therefore there are many solutions. We're not going to solve climate change simply with a solar panel, or by eating less meat, or not flying, or not using cement. We've got to do a little bit of all of that stuff. And usually, one of the repeating lessons we saw here is start with efficiency, wasting less energy, wasting less material, wasting less food. Those are all really crucial. And then switching what we do to something that doesn't emit greenhouse gases. We can still make electricity, but do it differently. We can eat food that doesn't emit greenhouse gases. We can make stuff and live in places and get around without any fossil fuels at all. So between efficiency, where we usually start, and transforming the economy to a low carbon economy, we have some great solutions to tackle climate change.